What's McCracken, rock stars? You are the stars of the show as usual, and today's show features you and solving multi-step linear equations. Okay, if you have not watched two-step linear equations, go back and check out that video. It will be very helpful. And I have one-step equations, all kinds of stuff related to equations. Go check it out. But today we are going to focus on you solving multi-step linear equations. Hey, what do you call a dinosaur with no eyes? I love this one. It's called Do You Think He Saw Us? Wait, yeah, do you think he saw us? Maybe it was Do You Think You Saw Us, Rex? I don't know. I liked it. All right, so today we're going to apply the properties of real numbers and the properties of equality to solve multi-step linear equations in one variable. So basically what that means is when you had one-step equation, it was like x minus 4 equals 8. We were simply going to move that minus 4 to get x by itself. Two-step equations, you had multiplication and addition, or division and subtraction, but there was two steps. Move an addition, subtraction, and then you're going to move the multiplication or division. Well, now there's going to be variables possibly on both sides. You might have a lot of other things going on, like the distributive property. You may have to combine terms. But eventually, what's cool about this is you go multi-step, and as we go, you're going to find yourself getting down to, oh, there's the two-step equation. And we're going to keep going like, oh, there's the one-step equation. And then you're going to get yourself to the variable at the end, which is what you want. The variable equals something. That's our goal. All right, so let's talk equations. Remember, equations are like a balance. The equal sign is the balance point. So whatever's on one side has to have the same value as whatever's on the other side. And it may not look as simple as 15 equals 15. It's going to be a bunch of mumbo-jumbo coefficients and terms and all kinds of stuff, but it has to be equal. And we have to keep it equal the entire time. Let's review our keys real quick. There's 4 that we've talked about already. The inverse operation understanding is the key. Inverse operations are addition and subtraction are inverse operations of each other, which means they are opposite. Operations means, addition, subtraction, multiplication, division are our 4 operations. So the inverses are addition and subtraction are opposite each other, and multiplication, division are opposite each other. You're going to need that when you're manipulating an equation. Key number 2, flippity flip. When you're simplifying expressions, you use GIMDAs. When we get to the point where we're moving equations, things across the equation, we use GIMDAs backwards. In other words, we start with addition and subtraction and go towards groupings, okay? Third key, again, these are reviews. Reminder that when I use inverse operations on one side, I must do the same on the other. So in other words, what I do to one side, I have to do to the other. I have to keep it balanced, all right? Review key number 4, let's just understand the parts of equation because you're going to need this, especially for the combining terms portion of your equation. This is called the coefficient. It's a number that's connected to a variable, which means it's being multiplied by or it's being divided by. In this situation, it's connected to the x, which is the variable. It's the unknown. It's what we're trying to solve for. Okay. We have constants, which don't have a variable connected to them. Those are our integers, our fractions, our decimals that don't connect to anything. It's just they're standalones. And then we have this thing called operator in the middle, like as addition, subtraction, multiplication, division. Those are our operators. And finally, we have terms. Every one of these sections, this is a term. This is a term, and this is a term. And if you haven't watched my combining like terms video, I highly recommend it because you're going to need it for this one. So understanding what terms are is crucial. All right, so here's our new key. Key number 5. When you see either side of an equation with the need to use a distribution property, do that before you do anything else. If you haven't seen that distribution video, it's about Oprah telling everyone that you get a 4 and you get a 4. In this situation, here is a -4, okay? We have -4 connected to a parentheses right here, okay? So, according to the distribution property, we have to say you get a -4 and you get, well, let me erase that so you can see a little better. You get a -4, which means -4 times -3, and you get a -4, which means -4 times a positive 2x, all right? That's what the distribution property means, and we'd have to do that on both sides. Over here, we'd multiply everything inside of it by -3 because we're distributing that 3. We do this first. Get rid of those parentheses so we can head on to the next one, which is combining like terms. Before you start doing GIMDAs backwards, combine all the terms on one side, and then combine all the terms on the other side. So in this one side over here, we're going to look at this side first. I have terms that match, okay? I have a coefficient touching a variable, and the variable's x. So both of them are a coefficient touching it, so I can go ahead and combine those. There's nothing else I can do on that side because the other term I have is a -2, and that's the only thing over there, so I just leave him alone. And then on the other side, I would look and say, oh, I got two constants. I have a 17 and I have a positive 2. And they don't have any variables connected to them. So they're on the same team. We're in the same jersey. Let's go ahead and combine them to one number, okay? Okay, so let's dive into this real quick and let's review how we do two-step equations. So remember, get the variable by itself. That's the first goal. Number 2, we're going to use reverse GIMDAs to get there. And the third thing we're going to think about is the inverse operations to get the variable by itself. So again, this is a review. Here's a quick review of 2x minus 8 equals 10. All right, first thing first is we want to get that variable by itself, and now we're using reverse GIMDAs. Okay, do you see, so we start at the bottom. Do you see any addition or subtraction? Yes, I do. I see minus 8, 2x minus 8. So I see that, so I'm going to do the reverse of that. All right, so I'm going to add 8. That's the inverse. Whatever I do to one side, I have to do to the other. There it is. And then I just simply simplify from there. All right, so negative 8 and a positive 8, they cancel each other out to be a 0. And then on the other side, I got 10 plus 8. So we're going to add those together, and we're going to get 18. And then next thing we do is just bring everything else down that was left over. So this canceled out, so we can get rid of all that. And we bring the 2x and we bring the equal sign down, okay? So now we have 2x equals 8. Do we see any more addition or subtraction? No, we do not. We have 2 times x equals 8, right? So now we're going to multiplication division. We do have 2 times x. So what's the inverse of that? Divided by 2. So if we're multiplying by 2, the opposite is dividing by 2. And what I do to one side, I got to do to the other. So I divide by 2. All right, so here we go. 2 divided by 2 equals 1. So that means we have 1x, so they cancel out. And on the other side, I have 18 divided by 2, which equals what? 9. And then I bring everything else down. X. When we divided 2 by 2, we only got rid of the 2, which means we just have 1x left over. So x equals 9. And that's your final answer. And that's how we would solve that, okay? So let's update the steps when we're doing this, because you know the steps for two-step equations was we do reverse GIMDAs, and that gets us to where we need to go. But before we get to before we get to reverse operations, reverse GIMDAs, we need to update this. So first thing we're going to do is get the variable by itself. That's our goal. That's not what we do. That's the whole process, is getting the variable by itself. The first thing we're going to do is, do we see any distribution property? Is any of that needed? If so, do it. After that, combine terms on each side. If you got that done, if there's nothing to do, then you can move on to step 4, which is moving day. Get the variables all on one side. So we move, if we have 4c on one side and 7c on the other side, we're going to move one of them to the other side just to get the variables all on one side. Then after that, it's reverse GIMDAs again. Get reverse GIMDAs going, and then inverse all operations to get the variable by itself. All right. So we already know 5 and 6. We've done that a lot. Let's dive in and see what this looks like. Okay, so let's solve a multi-step equation, and here it comes. There's our reminder list of what to do, and our goal is to get the variable by itself, and good golly, Miss Molly, look at all that stuff. Well, what's the first thing we want to do? Distributive property. Do you see anywhere where there's a distributive property needed? Yes, right there, because I have 2 touching a parentheses, which means I'm going to distribute that 2 to everything inside the parentheses. So here's what we're going to do. We take 2 times x, and we take 2 times negative 4. All right, so this is what it gives us. 2 times x is 2x, and 2 times negative 4 gives us negative 8. And every time after you do a step, this is how you show your work. Every time you do a step, you simply bring everything else back down so you can get to the next step. All right, so I'm just going to bring all that back down. I brought the 4x equals 10 minus 2x plus 6. Good to go. All right, any more distributive property? No, there's not. So we go to the next step. The next step tells us to combine terms on each side. So I sometimes tell kids to go ahead and put your hand over one side so it doesn't mess with you. And we're just going to do this side first. And we're looking for terms that are alike. And in this case, I have a 2x and I have a 4x. Those terms are alike. They're on the same team. All right. So what does that mean? We go ahead and combine them. What is 2x plus 4x? Well, we have 6x. Okay. And then after we do that, we bring down everything else that's on that side of the expression. So I bring down the negative 8. I'll go ahead and bring down the equal sign. And now we go ahead and move to the other side of the expression. Is there anything I can combine on that side? Yes, there is. I have the constants I can combine. I have a 10 and I have a positive 6. Okay, can't do anything with that negative 2x yet because there's no other terms with them. But I can go ahead and combine those two, and a 10 and a 6 equals 16. Go ahead and bring down what's left over. Negative 2x. All right, You have distributed and you have combined. Now we can move on to the next step, which is what? Moving day. All right, so let's get into moving day. What does that mean? That means get all the variables on one side. And you can tell right now, I have 6x's on this side and I have negative 2x's on this side. And moving day says, let's move one of them. All right, and you can move whichever one you want to. I'm going to move, I got a positive 6 over here, and I got a negative 2x over here. So I know enough about solving equations that I'm going to have to do the inverse operation to move it over there. So I'm going to turn that into a positive x. So I'm going to do that because I like working with positive numbers more than negative numbers. So I'm going to move that negative 2x to the other side. And how am I going to do that? Okay, I'm going to do, it's minus 2x, so I'm going to go ahead and add 2x because that cancels it out. That gets rid of it. But it also moves it to the other side because what I do to one side, I have to do to the other. Okay, now, so negative 2x plus 2x gets canceled out because that equals 0. And on the other side, 6x plus 2x equals 8x. What do we do next? Move everything else back down. So I'm going to move down minus 8 equals 16. I'm done with this, so I don't have to bring it down anymore, okay? Now, what's the next step? Okay, is there any more moving day I need to do? No, I got all the variables on one side. So now, look at what you see there. That's a two-step equation, right? That's a two-step equation. I'm going to do this, and then I'm going to do that. If you understand two-step equations well enough, you can see it all right off the bat. But if you don't, let's just go back to reverse GIMDAs, all right? Reverse GIMDAs and inverse operations tells us to do what? Start at the bottom of reverse GIMDAs, which is addition and subtraction. Notice I just circled it up there. And what am I going to do with it? I'm going to do the inverse. So, do I see any addition or subtraction? Yes, I do. I am subtracting 8. And what's the inverse of negative 8? Well, that would be a positive 8. And what do I do to one side? We got to do it to the other side. See how this just keeps happening? It's a pattern. All right, so let's go ahead and do that. Negative 8 and a positive 8, those are 0 pairs. They'll cancel out and give us a 0. 16 plus 8 gives us a 24. Just like all the other steps, bring everything else back down. Booyah, now we have 8x equals 24. All right, final step. Do you see any more addition subtraction? No. Do you see any multiplication and division? Look up here, we're going backwards. Yes, we do. We have 8 times x. So we're going to use the inverse of times multiplication. We're going to do division, which means instead of multiplying by 8, we are going to divide by 8. And what we do to one side, we do to the other. We should make a song about this. All right, and what does that mean? 8 divided by 8 equals 1. So if I have 1x, what do I have? I just have x. And 24 divided by 8 equals 3. So we bring the x and the equal sign down, and we get the answer to our multi-step equation. Now, there's a lot of things that can go wrong there, isn't there? So let's show you how you can make sure you answer this correctly, okay? So we know our answer is, we figured this out to be x equals negative 3. So we're going to go ahead and plug in the 3 to the x's on one side of the equation. So let's just go ahead and replace the 3 for the x and check and see if each side equals the same thing, okay? So let's plug that x in. You see what I did there? X equals 3. So I put that in for x there, and I put the 3 in for x there, right? And this is 4x, which means 4 times x. So that's why this says 4 times 3. And now we just use order of operations, all right? What do we know about order of operations? Because we're just dealing with an expression. There's no more variables. We don't need to use the distributive property. We just use the order of operations, all right? And the order of operations says do the groupings first. So inside that parentheses is 3 minus 4, and that equals negative 1. 3 minus 4 equals negative 1, so I bring it down, and I bring everything else down. All right, what's the next thing we do? Okay, next thing we do is exponents. There are not any exponents. So then we do multiplication and division in the order we see them. When a number is touching a parentheses, it means multiplication. So we do that first. What's 2 times negative 1? That's negative 2. And then you bring everything else straight back down, okay? What's the next thing we're going to do? We're going to do multiplication again because we have another one. What's 4 times 3? That's 12, and we just brought the negative 2 down with it. And now we're at our final step. We just have negative 12 plus 2, and that equals what? That equals 10. Okay, so we plugged in the value of x, which was 3, to get that. And now we're going to do the same thing on the other side, okay? So let's plug in our value of x, which is 3, there, and write our new expression over. 10 minus 2 times 3, because this is times x, plus 6, okay? Do we have any, now we're going to do reverse, I'm sorry, now we're going to do GIMDAs. It's an expression, we're going to do it in the right order. Do you see any parentheses or groupings? No. Do you see any exponents? No. Do you see any multiplication or division? Yes, I see right there that I have multiplication. All right, that's the first one I see going from left to right. And what is negative 2 times 3? Well, that equals negative 6. All right, so then we bring everything else down with it, and we get 10 minus 6 plus 6, okay? Now, all we have left is minus and addition. So we're at the last steps of GIMDA. So we do the one we see first, which is 10 minus 6, like you're reading a book, all right? 10 minus 6 is equal to 4. Bring down what's left over, plus 6. And what's 4 plus 6? That's our final step. It equals 10. So if you solve this right and you plug in the value of your variable, we plugged in the 3, and the 3. And then you solve each side of the expression, right? We solve each side. And they are the same thing. 10 is equal to 10. Well, that sure sounds like an equation worked. And we give ourselves a big old check mark and we celebrate with a dance of happy multi-step equations. Let's go. And that's how you can check your work. Just plug in the value, check it real quick, and see what you got. All right, so let's go ahead and fill in some blanks. You know how to do multi-step equations now. What is the goal of an equation? Getting the variable by itself. It doesn't matter how much junk is in this equation, we are getting the variable by itself. What is the first thing we look for when solving multi-step equations? The distributive property. Is there any place where I can distribute? Next, we look at what? We look at each side of the equation to see if we need to combine terms. Yeah, we got to combine terms. You don't have to do this. It just makes your life a lot easier because then you're just moving stuff all over the place. Once we combine terms, if we have variables on both sides, it's called moving day because we're moving the variables all to one side. They all got to live in the same part of town. 5, finally, we just follow the steps for what? Two-step equations. And once you do that, once you follow the steps for two-step equations, you're going to realize that you have seen that before, and you're going to get to what our ultimate goal was, which was getting the variable by itself. All right, you guys are ready to go. Hey, what do you call? That's a little slip. What do you call it when a dinosaur makes a goal? You call it a dinoscore. As a dino goal. Let's go.